Hey guys, this is Carrie, and in this video we're going to be looking at two different encryption and decryption algorithms. So we've actually talked about these already, hopefully through the do now and the lesson. But as we get into programming, we're going to start off by creating an HTML file to encrypt messages using the every other letter is fake algorithm. Okay, so the way that this algorithm works, right, is if you took a word like hello, we want to turn that word into H-E-L-L-O, and then have a random letter in between each one of these actual letters. Okay, so now that we understand how the algorithm encrypts things, let's take a look at actually encrypting stuff. So I'm going to give this a save, and I'm going to go to my desktop and files for video, and I'll call this problem1.html. Okay, so we're going to start the same way that we have been. So we generate the basic HTML structure. Next up, we're going to open up the toolbox. And we're going to grab the expansion pack for the AP tools because we're going to be using those. So there we go. Now, also, we need to create our own script tags. So we create our own script tags here. And the first thing that we're going to do is you were sent an email, and it's got the alphabet for you. So I'm just going to go into, I actually already did these this morning. I'm going to go into one of those, and I'm going to grab this alphabet thing. You can find that in the email that you were sent. And so this is a list of all the letters in the alphabet. And so just to get a feel for how this list works, let's open up this file in our browser. We're going to open up the JavaScript console. And now that we've defined this alphabet variable, we have access to it down in the console. So if we type in alphabet, it shows us the alphabet. And the only reason why this appears here is because we've created that variable in our JavaScript code here. Now there is a bit of a problem though. In JavaScript, if we do alphabet and then we find the one at the first index, it gives us B. And if we look through our list, we're expecting to get not B, the one at the first index using the AP pseudocode language should be the one at the first index A. So to make things match up, we're going to change the alphabet slightly by putting a comma before the A. This will shift everything to match our expectation with the AP pseudocode language we've been working with. So let's save it and refresh it. Now if we type alphabet 1, that gives us A. Alphabet 2 gives us B, just like we'd expect. Alphabet 26 gives us Z, just like we'd expect. All right, so let's think. If we want to encrypt this, basically we need to define a function to encrypt stuff. But if we think back to how we were encrypting things, we had to generate random letters. So that should make us think about a function that we worked with last time. If we're going to generate random letters, the thing we worked mainly with was generating random numbers. So at this point, it would be good to go back into our code from 2 classes ago, lesson 4, and that generate random function is going to continue to be useful for us. So let's grab the generate random function. So what this function does is it generates a random, not decimal from 0 to 1 anymore, it generates a random number from whatever the min number is to the max number. So if we wanted to save that and refresh this, now we've defined generate random inside of the function, so we can use that function here, generate random 1, 26, and this will generate a random number from 1 to 26. Now we can take this function and use it as a sub-algorithm for generating a random letter. So function generate random letter, and that function doesn't require a parameter. When we generate a random letter, what we're going to do is we're going to start by generating a random number. So let random number equal generate random, and the random letter or number that we're going to generate isn't spelled like that. Generate random is going to be from 1 to 26 because we want it to turn into a letter. Then we're going to let our random letter be alphabet at the index that we generate. So alphabet at this random number. And that should return, and then we should return the random letter that we create using this so we can have access to that random letter somewhere else. Just for the sake of illustration though, let's do console.log that random letter so we can see this in action in our console. So we're looking again at problem 1. I've just refreshed the web browser, and now we have access to this new generate random letter function. And if we use it, each time we use it, it should generate a different random letter. Cool. So I'm going to get rid of this console.log function. So now when we think about encrypting one of these messages, we should define an encrypt function. And that encrypt function should take in a parameter. That should be the message that we're trying to encrypt. Now, in order to encrypt this message, we might have a message like, I don't know, hello, and then that becomes H, random letter, E, random letter, L, random letter, L, random letter, O, random letter. So to think about this process, it's a little bit tricky. And we're going to need a couple of new functions in order to do this. So one of the new functions that we're going to need is, let me just clear out the console. Oh, that didn't work. Console.clear. Let me just clear out the console. I'll illustrate that function down here. So if you have a sentence like hello, and you want to turn it into a list, what you can do is you can split that sentence as follows. And so hello.split will become this list of letters. And that's actually really nice, because now we can go through this list of letters and insert random letters in between each one of them. So to do that, let's see how we would do it. We would say let message list, and it's going to be the same as our message, the same way that this hello is the same as this hello, but they're different data types. So let message list equal whatever the message was dot split, and we're putting in the empty character here. So we're telling it to split the string on every letter, and that's what this empty character means. You could have it split only on spaces, and that would split it into words, but we're going to leave it as split on the empty string with nothing in it. And you can use 2 quotes for that, because I know we usually use 2 quotes for strings. Okay, so now that we've got our message list, we're also going to define a new variable called let encrypted message equal the empty string. So we start off with nothing as our encrypted message, and as we go through this list of letters, we're going to be adding to our encrypted message the letter, a random letter, the letter, a random letter, and we'll build up that encrypted message slowly. So here we go. Since we want to go through it letter by letter, it sounds like a for each loop. So we'll do message list, that new list from our message, dot for each. And if we think about going through this list, I think a good descriptor of each thing as we go through it would be, this is a letter, this is a letter, so let's call each one of these letter. And that letter, what do we want to do with it? What we want to do is we want to do encrypted message is going to equal whatever the encrypted message was originally plus that letter. So the first time through, we'll add on H to it, because that will be the first letter. But now instead of just going through and adding letter by letter to our encrypted message, what we want to do is we want to add a random letter here as well. So let's let random letter equal generate random letter. And then what we'll do is we'll add not just the letter that we were currently up to in our encrypted message, but we'll also add to the encrypted message the old version of it plus whatever random letter we just created. So we're going to add the current letter H, generate a random letter, and then add that random letter. The next time through, letter is Z. So we add E to it. We generate a random letter, and we add that to it. And then finally, at the end of this, we're going to do 2 things. We're going to display the message. Oh, but it's not the message we want to display. We want to display the encrypted message. And then we also want to return the encrypted message. And that way we have the encrypted message as an output that we could use for something else. So let's start by encrypting our test case, hello. So we save it, we refresh it, and now we've got a version of hello. Let's see if it works. H, random, E, random, L, random, L, random, O, random. That looks pretty good. So let's encrypt whatever message you want to encrypt. I don't know. You have been hacked. And it looks like total gibberish, but we know how this was encrypted. So the next part of this is there a way that we can take an encrypted message and decrypt it? And that's going to be problem 2. So let's start off with problem 2. So for problem 2, we're going to begin the same way. Generate the basic, actually, you know what? The easiest way to probably do it is to copy and paste what we just did. Now, we're not going to need a lot of these functions anymore. We no longer, when we're thinking about decrypting this, it's not that we need to generate random numbers. We need to kind of generate random letters. We need to get rid of these random letters. So we're not going to need these functions anymore. In fact, the only function that we're going to need is a decrypt function. So I'm going to comment out this encrypt function, and then we'll think about what it means to decrypt a function now. So function decrypt. And that, when we decrypt something, we need to take in the message that we're going to be decrypting as a parameter. So let's start by creating a decrypted message. And at first, we have no idea what the decrypted message is, so it will be an empty string. We also need to, let's see, looking back at the problem before, we also need to take that decrypted message, or sorry, the message that's currently encrypted, so something like this, and we're going to need to split it up using that .split method. And now that will create a list of these. And it looks like the goal with it is whatever we want to decrypt here is we're going to go through it letter by letter, and we'll keep the first one, get rid of the second. Keep the first one, get rid of the second. Keep the first one, get rid of the second. And we'll just go through letter by letter, alternating between keeping it and not keeping it. Keeping it and not keeping it. All right. So in order to split our message up, we say let message list equal whatever the message was as a string, and then we're going to split it up just like this so that it creates a list version of the message, which is able to be treated letter by letter. So because it's a list now, we can go through it letter by letter. So message list dot for each, and as we loop through it, a proper name for each one of these things could be letter. So let's go through it letter by letter. And what we're going to do is we have to keep one, get rid of the next. Keep one, get rid of the next. And this is a little bit maybe tricky to do. So there's a lot of ways you could program this, but one that I was thinking of was we could start off by saying it's true that we want to keep the first one. So let's define a variable here, and let's say let keep equal true. And then what we're going to do is, if we're supposed to keep that letter, if that's true, then the decrypted message should add that letter, should equal the old decrypted message plus that letter. Otherwise, we don't want to do anything, so we're not even going to write the else. We don't want to add the letter if we're not supposed to keep it. Now, the important part is every time we go through it, keep needs to switch back and forth. And so there's a lot of ways you can program this, but perhaps the most obvious one is if keep is true, then we're going to set keep to false, because the next time through we don't want to keep it. Otherwise, we'll set keep to true. So if keep were true, then it becomes false, so we're not keeping the next one. But then the next time through when keep is false, this isn't satisfied, so then keep becomes true again, and it switches back and forth between the two. So now we want to do two things here. After we decrypt the entire message, we want to display the decrypted message, and we want to we want to return the decrypted message in case we want to use it for something else. So now we're not encrypting anymore, we're decrypting, and let's start by decrypting this message that we got here from our last file. So we'll give it a save, we'll open this one in the browser, and when we decrypt it, we get you have been hacked, which is the decrypted version of this. So our two problems work really well together. Let's start by encrypting a message here. I don't know, hello world. So save it. We go to problem 1, which is our encryptor. We encrypt it. So if somebody sends us this message, now we can copy it. We go to problem 2, and we plug that message into our decryptor. And we switch to our problem 2 window, and we refresh it here, and we've got hello world. So that's a nice way to encrypt and decrypt messages using this random letter, every other letter random algorithm.